equals 2/7. I never get to stop here because I always have to check that these numbers do not make my numerator 0. So I will plug back in. So I just have to plug it into 6 times negative 5 halves minus 2. Is that going to be 0? Well, let's see. I'll have negative 30 halves minus 2. That's a nice negative number, so it's not 0. That means I get to keep this one. And on this one, I will have 6 times 2/7 minus 2. Let's see. Is that going to cause a problem? 12/7 is not quite 2, so minus 2 is not going to be 0, so this is not 0. That means I get to keep this one. How do I write vertical asymptotes? What kind of lines did we say they were?
X equals.
Vertical lines, so x equals is all you need. X equals negative 5 halves, x equals 2/7. In web work, if you have more than one, you will write x equals 5 halves, comma, x equals 2/7. You can write them both in there. You need an x equals with both pieces. Now what else were we supposed to find? Horizontal asymptotes. I gotta keep my function up here. We're gonna use. So, my horizontal asymptote. What is a horizontal asymptote? It's a line, horizontal line. What about a horizontal line? Yeah, but what is a horizontal asymptote in relation to this function? Anybody know? And this is why I only vaguely said this on Friday and then just left it that we would take care of it today, because I figured nobody would remember. Basically what it's asking is, as x approaches infinity, what happens to this function? F of x is going to go somewhere. Horizontal asymptotes are end behaviors for our rational functions. So, when we're getting really big numbers, what's going to be important up here? Is that minus 2 going to mean anything if I have 1,000,000 for x? No. So really the only important thing here will be the 6 and the x, because that will make like 6 million, but 6 million minus 2 is going to be useless. The minus 2 part will be useless. What about in this piece? What's going to be important in that piece? The negative 2x. And what about in this piece? What's going to be important there as x is getting to be really big? It'll be the 7x. Now, if I simplify this, this will be 6x divided by negative 14x squared, which will be, you guys want me to simplify the 6 and the 14? Or do you care? Do you like it simplified? Okay, so 3 over negative 7x. Now let me ask you about this. As x is getting really big, what is happening to this fraction? It's getting really small. Really close to what nice small number? 0. So this is approaching 0 as x is getting really big. So that means we would say that the horizontal asymptote is y equals 0. In terms of our function, what that means is that as the function keeps getting bigger and bigger and bigger for x's, the y values are getting closer and closer and closer to 0. At no time does it indicate that they cannot be 0. You can go back and forth across. There are some functions that you can run into that have horizontal asymptotes, and it'll go back back and forth around the asymptote, but keep getting smaller and smaller and smaller, and it will still have a horizontal asymptote. You can cross the horizontal asymptote. Did this graph ever cross y equals 0? Gigi's finally going, yeah, because I gave her this look. Where did it do it?
0, negative 1,
Is that what it was?
think so, yeah.
Yeah, and that x-intercept that we found. Y equals 0. Oh, you got the wrong one. At the x-intercept that we found. Because this is the x-axis. Yes? We did cross over y equals 0. But what this is saying is as x gets really, really big, what is this graph starting to look like? And it's starting to look like a horizontal line at y equals 0. It never actually is 1, but it starts to look an awful lot like 1. Now, you now know how to find an x-intercept, a y-intercept, vertical and horizontal asymptotes, and so I'm going to give you a problem to do. I want you to find just the vertical and horizontal asymptotes for this function. F of x equals 7x minus 6 times x plus 5, all divided by negative 6x minus 4 times 5x minus 6. So you're supposed to find the vertical asymptotes. If there are any, and the horizontal asymptotes. By the way, is it possible for there to be more than one horizontal asymptote?
No.
No, because it's basically saying what does your graph look like as it gets really big. It's not going to look like two different things because then your graph would be in two different places, which would make it have two different y values for x's. It's not a function, and these are all functions. All right, so go work on that. Let's see what you get. What about this one? So I'm going to let you do another one.